This video is going to have a look at how we know water is safe. By the end of it, you will know the test for the anions, including bromine, chlorine and iodine. You will know the silver nitrate test, you will know the test for ammonia, and you will know how to write ionic equations. So in water, we can have ionic compounds, as I covered in the previous video. What we're going to have a look at now is how we can test for these anions. So the Halide Ion Test is nice and simple. You add silver nitrate. When acidified with a little bit of nitric acid, a precipitate will form. And the three colours that you need to remember are: chloride ions will turn the precipitate white, bromide ions will turn the precipitate cream, and iodide will turn the precipitate yellow. Now what's happening in this reaction is sodium and chloride and silver nitrate are reacting together to form sodium nitrate. Now all nitrates, if you remember back to the solubility lesson, are aqueous, so they will all dissolve. But silver chloride is one of the ones that doesn't. So this is your precipitate. Now if it's silver chloride, as I've said, you'll get a white precipitate. If it was sodium bromide, you'd get silver bromide, and that would be cream, and then the iodide would be yellow. The final test is for ammonium ions. Ammonium are NH4 ions. Now, although this is technically a cation, it's positive, so it's still classed as a non-metal anion. So, what happens is we've got ammonium chloride, and we're reacting with sodium hydroxide exactly the same way. If you think back to the previous video, a reaction will occur when you heat it, but nothing will appear, there will be no precipitate, it will stay colourless. So what will happen though, is a gas will be given off, and this gas is ammonia, and the ammonia will start to turn blue litmus paper red. So that is how you can test to prove that ammonia ions are present. The final part of this video is going to show you what an ionic equation is and how to write it. The first thing you need to know when writing these is whether something is soluble or insoluble. So silver nitrate, all nitrates are soluble, so we can say that is soluble. Salt, soluble. Silver chloride is not, so that one is a solid. And then sodium nitrate, again, all nitrates are aqueous. So the next thing we can do is we can say that these anions and cations are free to move when they're dissolved and put into a liquid, so we can separate them out. So silver nitrate goes to Ag plus and NO3 minus. Sodium chloride goes to Na plus Cl minus. This doesn't separate, so this stays as AgCl because it's a solid. Then we get sodium, which is Na plus again, and NO3 minus. So that is just writing out the ions where they dissociate and turn back into their ions when dissolved. And the only one that doesn't is anything that becomes solid. Now, an ionic equation is showing anything where a change has occurred. Now if we have a look here, silver has gone from Ag plus into a compound of AgCl. The NO3 is the same before and afterwards, so we can rule that out, we can cross it out. Sodium, Na plus, so we cross that out. And then the chlorine has gone to AgCl. So if we wanted to write an ionic equation for this reaction here, of silver nitrate plus sodium chloride, it would be Ag plus Cl minus goes to AgCl. And that's what an ionic equation is. I'll just give you another example in a second. So here's another example where potassium iodide is reacting with silver nitrate to make potassium nitrate and silver iodide. So the same thing occurs, you put the ions And because that's a solid, it stays as a solid. So the next thing you do is you cross out the things that are the same on both sides. And that leaves you with and that's your Ionic equation for that reaction. This is probably the trickiest one you would come across in the exam, so have a look at it, pause the video and see if you can have a go at it. Remember, split them into the ions first and then have a go at figuring out what will happen. So this is what you should have got for the first step. This is what you should have crossed out, that's the same on both sides. And this is what you should have got for your answer. So NH4 plus OH minus goes to NH3 plus H2O. You can start to see from this is what's involved in the actual reaction. Okay? If you've got any questions with that, come and see me at any time.